So we got various attributes. On the top, if you see, we need to have a valid next hop in order to be used by the BGP forwarding database. BGP forwarding database will recommend a route to the routing information base only if the next hop is valid and the route is best. So what if I have more than one valid next hop, means more than one route to the same destination with valid next hop? Then it is going to check the weightage if anything set by us. You see, there are two next hops for the same destination. Two next hop for the same destination. Each next hop is a neighbor for you. Let me draw. This is a router. It shows next hop as A, next hop as B, in order to reach someone in the internet. So MR has got two gateways, A and B. A here is the next hop. Usually, next hop address is the address with which you are peering, with which you are forming neighbor. When both the next hops are valid, both cannot be best. You remember we saw BGP will not do load balancing. It is not designed to do load balancing. If you say this, people will argue with you. Just smile and go away. You can do manually load balancing, policy based. But by default, BGP will not do load balancing. It cannot do load balancing. Fine, then it is going to pick one, either B or C as a gateway to reach 1111. Based on what? Based on the weightage, if set. By default, weight for a neighbor is 0. MR router has got 0 weightage to A and B. That's the default weight. But when I set weightage as 10 for gateway A, if I go to MR and say neighbor A, weightage 10, weight 10, A will become the exit. Both B and A advertises the same 111 network, but because A has got more weightage, A is the preferred exit. Next is local preference. There is a big difference between weight and local preference. Weight is only on that router MR. Local preference is for the entire autonomous system. For example, if this is an autonomous system, I'm going to set high local preference here. For example, the default is 100. I'm giving 110. So Mr. A will prefer to go via this way. Not only Miss MR will go via A, even B will prefer to go via A. Every router will go via A. If I have C connected to A and B, even the C router will go via A because A is set as high local preference. Because the word local, it doesn't mean it is local to the router. It actually means it is local to the autonomous system. It is for the entire autonomous system. You may configure locally on router A, but that will be globally advertised to everyone inside this autonomous system. It won't go to the next autonomous system. It will be advertised only to all the routers within the autonomous system. So local preference that is set on one router higher will be known to everyone, and everyone will start to follow that one who has got the highest local preference as the exit. So even though B knows a direct path, even though B knows a direct exit to 1111, it won't go directly. It will go via Mr. and A. It will go via MR and A. We have seen this earlier with another example, but I'm just walking you through this iteration, attribute iteration. When a packet wants to go to a destination, first thing it will check whether I have a reachable next stop, valid next stop. Secondly, if there are multiple paths with valid next stop, it will check whether any one of this path has got, any one of this neighbor has got more weightage. If no weightage set, or if there is a tie-in weight, then it is going to check whether any local preference is set. See, only if weight is a tie, only when weight is a tie, it will prefer the neighbor whose local preference is higher as the exit, as the outgoing. Now, what if I don't set weight or local preference and I got a valid next stop? There is a tie. If there is tie in the first three, only then it prefers the route originated by the local router. But even though it is coming as third attribute, what Cisco has done is, see, as per the standard, it is coming as attribute 3, local origin. You remember, the local origin will have next stop 000. Why? Because it is locally connected to the same router. See, there is a place called Paris. If someone is talking about Paris in Chennai, they mean Chennai, Paris. It's not Paris in US. Weightage is more to local Paris. So if these two are a tie, when the next stop is 000, I've shown you Cisco, it will increase the weightage automatically to 32768 so that there is no more tie. This will become a tiebreaker. Meaning, because more weightage is given to the local, even if someone gives the route for the same network, that is not going to be preferred. So basically, the attribute third and attribute one are connected. If attribute 3 becomes true, the weightage for the network goes to 32768. And that is in Cisco only. Next. Only if there is tie in the above 3. Then it compares the path. If one path has got shortest AS than the other, if one path has got shortest autonomous systems hop count of the autonomous system, the shortest AS path will be preferred. What if there is no shortest AS path, all are equal? The destination is via two different AS, but the number of hops between is same. Only then it picks the path whose origin code is I. I is preferred over EGP. E. E is preferred over question mark. Lowest. See, I is lowest. Usually, I means IGP routing protocols, but here I represents BGP's own network. It is internally advertised. It is advertised using network command internally in BGP. I is preferred over E, as I told you earlier. Once upon a time, we had a protocol called EGP, the older version of BGP. So if you don't have I, it will check whether you have E so that it can prefer E rather than going with question mark. Question mark is the least preferred option. Question mark comes only when we have redistributed network. If someone takes a route from OSPF and redistribute it into BGP, then BGP will show the origin code as question mark. Lowest origin code. Next. Prefers lowest MED, multi-exit discriminator. Prefers lowest MED. Again, I'm telling you, only when there is tie in the first 5 attribute, lowest MED path will be preferred. Again, MED is not going to be applicable in all topology. In some topology, after this, it will check this, because this one is meaningless for the topology. For example, when I have an autonomous system connected like this, we call this as multi-homing. MED will never come into picture. MED is applicable only if you have multi-exit. For this autonomous system 10, do you have multi-exit? Meaning multi-exit means you need to have two exit going to the same autonomous system on the other side. It is not true. It's not true. It is connected to two different autonomous systems. Though it looks like multi-exit, but they are not connected to same autonomous system. Different. So even if you set MED here, default is 0. If you set MED here 10, don't expect the packet to go this way. No. Even though MED is 0 here, it's not guaranteed that it will go that way. Because of some other attribute, it will still go via this way. It will never consider MED if you don't have dual homing. If you don't have dual homing, never ever considered. In case if I have like this, autonomous system 10 and autonomous system 20. In this case, this is going to be preferred. Again, there should be a tie in the first 5 attribute. Only then, correct. There should be tie in the first 5 attribute. Only then the 6th attribute will be considered. So 2 things. One, there should be tie in first 5 attribute. Secondly, it needs to be a dual homed, not multi-homed. Dual home means what? Connecting to same ISP with more than one connection. And learning route from both the links. Same routes, learning from both the links. So prefer lowest MED is not always applicable. Don't try simply configuring MED when you don't have dual homing. Next. If up to 7 attribute is a tie, meaning you cannot 6 attribute, you cannot have MED, or you may have MED and it is 0, 0. Same MED. You may have dual homing, but MED is not set by you. And what it will do? It will check whether one of the neighbor is IBGP, another one is EBGP, and it prefers the path which is EBGP. For example, this is IBGP. These two are having IBGP relationship. And these two are having EBGP. This is different rooms. So instead of going via IBGP, it prefers EBGP path. Again, I'm telling you only if there's tie in the above. Don't forget, preferring EBGP over IBGP is not the very first attribute. Someone will say something, and the other will say, it is because EBGP is preferred over IBGP. You cannot say like that blindly for BGP. That's wrong. No, it's because BGP prefers EBGP over IBGP. Yeah, but it is attribute number 7, no? So we cannot simply take when someone says that statement. First of all, we need to check whether there is a tie in the first 6 attributes. Only then this preferring EBGP over IBGP is applicable. Some used to talk like as if, this attribute number 7 is the first attribute. No, it's the 7th attribute. Next. Especially when you're trying to find some solution in the internet. A lot of gossips. Lot of stories people write. Whatever they think as right, they say that is what correct. And they write it. And some people, they take it as a very holy one and they discuss with us. So beware of what you read, from where you read, what is the source. All forums, don't go with. Are you reading from a Cisco document, Juniper document, or at least from a Cisco community? Then okay. No other things I depend on, I rely on. I don't rely on the other things. They write too many stories. Whatever comes in their mind, they write. Okay. So BGP, EBGP preferring over IBGP is only attribute 7. Now, what if there is a tie in all this? See, if there is if there is no if there is a tie in this, what does it mean? It means that both should be EBGP or both should be IBGP. Preferring EBGP over IBGP. If that doesn't happen, that means both the neighbors of yours needs to be IBGP or EBGP. So first what it does is it checks the IGP. For IBGP, what do you have? IGP reachability, correct? For IBGP, what is IBGP? Peer within the autonomous system. Within the autonomous system, how do you know which IBGP neighbor is closest? You have OSPF, or you may have RIP. So you have some IGP protocol. Here IGP means the routing protocol, IGP, like OSPF, EIGRP, RIP, ISIS. It prefers the path through the closest IGP neighbor. For example, I can go this way, I can also go this way. Both are IBGP. Both of these are IBGP neighbor. Now for this router, to reach this IBGP and to reach this IBGP, there may not be same cost. Maybe for example, I may have a gig wire, so cost is what? Here I may have fast Ethernet, so cost is 100. So which one is closest? The gig Ethernet link. So it will go via this way. Via the gig Ethernet. It will go exit or yeah, gig Ethernet because the closest IGP neighbor. If both are EBGP, then oldest route for EBGP path. If both are not IBGP, what does that mean? Both are EBGP. See, if one is EBGP, EBGP is preferred. If this is a tie, then which means both should be an IBGP or both should be an EBGP. If it is IBGP, look into the IGP cost. If it is EBGP, prefer the oldest route from the EBGP neighbor for the EBGP path. Meaning, BGP should take the exit via which the route was learned first, the earliest, oldest. Prefers the oldest route for EBGP path. Next, if there is tie in this, which means both EBGP neighbor gave the route at the same milli micro nano second. Both the EBGP neighbor gave the route at the same time. If one has given 5 seconds earlier, I would have preferred that one. But both are given at the same time, assumed, it's an assumption. What if? Then prefers the path whose router ID is lower. So definitely every router has got a router ID. And because it is between the EBGPs, so on WAN, everyone will have their own unique IP address on the interfaces. So the router ID cannot be same. If router ID is not same, one will be lower than the other. Prefers the path whose neighbor router ID is lower. What if the router ID is also a tie? Very, very rare thin case. Even the neighbor's router ID is same. It is only by mistake it will happen. What if mistake has happened? I have two EBGP neighbor. Unfortunately, both have got same router ID. And they are advertising same networks. Which gateway I should prefer? This one, 11th one, cannot be a tie at all. Definitely every neighbor's address is unique. Prefers the path whose neighbor address is lower. This is how BGP picks only one path out of many. Always one path. Always only one path. Any question? No. See, I want to repeat number 5. Number 7. 7 is EBGP over IBGP. That you understand. EBGP means between two different autonomous systems. IBGP means same autonomous. But the origin code is different. Their IGP, it is not IBGP, their IGP, what does it mean? The way in which the network is advertised, how the network is originated. See, there are three ways in which you can learn route. One, someone is advertised using network command. That's how we used to advertise, right? Any protocol, BGP or OSPF or RIP or EIGRP or ISS, you use the network command. No, not for ISIS. For the rest of the whole protocol. We use what? We use network command to advertise. The other way of advertising is what? Redistribution. That's how we advertise network. But there is also another way for BGP. BGP can learn from its older version called EGP. So it's totally different. See, the routing protocol BGP has got an older version called EGP. If I am learning route from the older version and from the newer version, which is I have to prefer the newer version. If there is no newer version, I'm learning from older version and the redistributed, then you prefer the old version better, not the redistributed. Again, I'm telling you, this is only for theoretical. There is no E anymore in any BGP appliance. We don't have the older version called EGP. There is no EGP. So it's only I recommended over redistributed. Network command over redistributed. One network can be advertised using network command, can also be advertised using redistribution. Yes? Correct? Am I saying right? So prefers the network command advertised neighbor than the neighbor who provides a redistributed route for the same network. Any other question?